All right. I added a camera. Here, I can push my mic out of the way now, and you can see the book. I don't know how clear it is. I might have to blow it up. Maybe even then, maybe even then it won't be readable, but at least there's a view of the book now. You can see I'm not just hallucinating or pretending. Okay. So I got about, I don't know, 45 minutes. Thought it'd be nice to work out some problems here. Without using a calculator, make a rough sketch of the graph. Y equals x to the third. So 1, 0 is 0. I gotta open my notes. All right, there's 1. And then I'm gonna go up here. I wanna change my stabilizer. Okay. So was that a, no? Hmm. They got a stabilization mode that you can use when drawing graphs, but I'm not really a big fan of. Let's turn down the pixel delay to 2 pixels. So can I write like that? Let's turn this up. Looks like I'll be using weighted right, maybe stabilizer to draw. Okay, y equals x squared. So one is, let's just do some quick points here. So when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 8. When x is 3, y is 27. When x is 4, y is 256. Right? 4 times 4 times 4. No, I'm wrong. Y is not 256. 4 times 4 is 16 times 4. Y is 64. I was thinking x to the fourth. All right. We won't really be able to map that one because we only have 20 here. I'm using, well, I could. Yeah, we'll map that one. All right. We'll go the other way. When x is -1, y is -1. When x is -2, when x is -2, y is -8. Yeah. Okay, so these are all just inverted. When it's -3, it's -27. And when it's -4, it's -64. Negative, negative. Okay, so it's obviously it's x cubed. We all know what this looks like, but I've got to entertain the question. So 1 1. Yeah, let's do it. Let's make this. Yeah, let's make this at least 40. So 1 1 would be like right here. And then negative 1 would be right here. 2 8. So that's 2. And then 8. Here, -2, 8. Here. And then 327, 8, 16, 24, 25, 26, 27. I don't like how much it'll hug the Y. So no, we're going to space it back out. 1, 1. -1, -1. 2, 8. 1, 2, 8. -2, 8. Wait, down here. 327. 1, 2, 3. 27. We already don't have it. It's going to put us, if this was 20, 24, that'd put us somewhere 4, 8, 12, 16, 24, 28, 27. On 3. 3, that's 20. It'd be way down here. So that's what the graph is going to look like. It's not the cleanest, but man, I still got to figure out how to use the curve. All right, let's switch to stabilizer. That's what we're looking at. All right. 5B. Back to a weighted brush. 5B says without using, yeah. Y is equal to x plus 1 cubed. I have an old sheet from my AP calculus class where it lists everything, like everything relevant to calculus, like functions, graphs, common derivatives, it just everything. I gotta dig through and see if I can find it. Over the years, I've specifically like thrown everything away, and I had keep finding that sheet, and I'm like, nah, I'm keeping this. This right here is like gold. I mean, I'm sure ChatGPT could spin one up, but the problem with ChatGPT is sometimes it'll miss something, and if I don't know and it doesn't know, then it's just the blind leading the blind, you know. So it doesn't help. All right, let's do one here. Let's build a set of so for 0, 0. No, yep, 0. No, actually, when x is 0, y is 1. When x is 1, 2, 3, 4. Put a little. And then -1, -2, -3, and -4. All right. 2, 8. So when it's 1, we're 8. When it's 2, we're 27. When it's 3, we're 64. So all this does is make it. It's actually pretty cool. It's a way to. Let me think about this. It's a way to make that value the next value's cube. Or what would have been the next value's cube on a standard x cubed graph. I want to see what this does. 4, so 5 cubed is 125. So -1 is 0. So it's only going to behave that in the positive domain. -2 plus 1 is -1 cubed, which is -1. -3 plus 1 is actually, I'm curious to see this. So this is going to be strange. -3 plus 1 is -2 cubed, which is -8. -4 plus 1, -3 cubed is -27. Yeah, so it's going to look, it's going to compress in different ways on the cubed. Okay, so we got a 0, x is 0, y is 1. So we moved up 1 on the y axis on the intercept. So 1, 8. Man, I almost want this to be 1, 2, 3, 4. I can make them whatever the hell I want. I mean, but you want a 1-to-1 relationship. Yeah. 1, 8. 227. 1, 2. So we already blown it off here. All right, we see the way that's going to trend. I need to redo the graph. I need to think about what might make the most sense. Because I don't like how this stuff's represented. Everything's so tightly packed because we're representing in ones, but it's the best way to do it. It's not. I think I should represent in fours. 4, 8, 12, 16. So I get 16 per. And then I have to plug fours into my equations to get clean coordinates. I don't know. There's really no compromise here. We'll just move forward with this one. All right, -1, 0. -1 is 0. -2, -1. -2, -1. They call that something. An inflection. I miss my teacher. -3, -8. -4, -27. Oh, actually, that's not 27. 27 would be way up here. Yeah, so this would actually be 27, not that. I messed up earlier when I shown 27 there. It's not counting. So my 27 would be down here somewhere. But now we're looking at something like that and that. Let's compare the two. So they both have a They're obviously both cubed. So they have a similar slope. The only thing the plus 1 does is move our, basically, the inflection point, or the point at which the graph switches -1. That's interesting. All right. Now we're going to represent in fours. I want to try fours here. All right. Shift W. Okay. So when x is 0, -2, so it's -8 plus 3, or 5. When x is 1, I'm going to start doing negatives over here. -1 minus 2, -3, -27 plus 3 is... Oh no, I said I'd do fours. -4. What's -4 minus 2? -6 cubed. What's 6 times 36? 180 plus 36, 216? I'm taking the, without using a calculator, too literal. I'm going to have to use a calculator to do the simple math here. And they just mean not plotting the graph. -4 minus 2, -6 cubed. -216 plus 3, -213. Even though I should try to do these that way. Yeah. -213, -8. So -10 cubed. Well, I know that one. That's 1,003. No, that's -997. I can't even represent that here, so I can't even work in fours. Is there no good way to graph shit? I gotta work in one, so what am I doing? These things get out of hand too fast. This is why we have calculators. I could stretch it. I could stretch it, you know, I could have it so that the y-axis is compressed relative to the x-axis. Like the x-axis works on 4s and the y-axis works on 20s. But I don't like viewing graphs that way, because most of the time when I look at a graph, I'm thinking about it compared to its fundamental form or a fundamental form. And I don't like having to factor in compression on an axis. It's just not intuitive. It's not clean. All right, -1, -3. So -27 plus -24. -2. See, we're already off the bounds of which I can capture here. It's okay. That is okay. That's okay. That's okay. We're just sketching. So that's what we'll do. We only have a single negative value then, because we're already below. Okay, so for +1, 1 minus 2, -1. So -1 plus 3. -1 cubed is -1 plus 3, which is 2. 1, 2. So for 2, 0 cubed is 0 plus 3. 2, 3. 3. 1 cubed is 1 plus 3, 4. Wow, this is a strange graph. 4, 2 cubed, 8, 11. 4, 11, and I believe this 5 will be our last one here. So we increase by 1. 1, 1, 7. What is Fibonacci sequence? 1, 1, 2, 3. All right, 5 minus 2, 3 cubed is 27 plus 3, 30. See, we already left the graph. All right, let's map this. So we got 0, 5, 0, y is 5, 1, 2, 3, 4, 5. I don't think this is going to be right. -1, -24. So we're all the way down here. Huh. I don't know. I don't know about that. 0 minus 2. Oh, I see. I did something wrong. This is actually -5. -5. Hmm. Really want to start doing it this way. I want to plot with a. So 0, -5. We're actually way down here. Let me check. Ooh. Yeah. So -1, we're -24. And then the marker is actually probably better. Probably a better solution here. Because I can just do points like this. Ooh, that's nice. And then 1, 2. At 1 word, 1, 2. Huh. And then we're 2, 1, 2, 1, 2, 3. And we're 3, 4. I don't like how big I made these. We're going to go smaller. There we go. 4. No, let's go to 6. 3, 4. 1, 2, 3, 1, 2, 3, 4. Why is that looking linear? 4, 1. No, 4, 11. 1, 2, 3, 4. There we go. That's what I expected to see. So that's 8, 9, 10, 11. 5:30. So if we go to 5, we're somewhere way the hell up here. So our graph will look something like this. So we kind of curve, we come up, we curve in, and we go back out. Another cube. Oh, I love how the cube looks. I love how cubed values. I love the cubed graph. It makes sense. It follows It follows the linear pattern. I hate the squared graph. I hate the squared graph. It's non-intuitive. It's non-intuitive. The cube graph is intuitive, buddy. All right. Next question. 5D. What time we got? 47? Man, it looks like it's time already. Oh, but let's try to squeeze a few more in. Okay. We're going to work fast. So, when x is 0, y is 0 squared, 4 minus 0, 4. When x is -1, -1 squared is 1 minus 1, 3. God damn. When x is -2, 4 minus 4 is 0. When x is -3, -3 squared, 9, 4 minus 9 is -5. So -3, -5. When x is -4, 16, 4, -12. Really, I'm just plotting them until I surpass 20, because you know my bounds are 20. So -5 is -5 squared, 25, -21. All right. When x is 1, or 3. Obviously, I know what this is going to yield because it's squared. It's parabolic. 2, 4, 0. So 2, 0. Negative, 3. 9, 4 minus 9 is what? Oh, yeah. -5. That makes sense. Y is always going to be the same because the x value always ends up positive. 4 squared, 16. 4 minus 16, -12. And this one I know. 5, 21. Man, 0, 4. When x is 0, y is 1, 2, 3, 4. Let's switch to our... Nope, that's not our point. 4. All right, -1, 3. I want to turn on my symmetry here because it's symmetric. Save me some time. When x is -1, y is 3. 1, 2, 3. When x is -2, y is 0. When x is -3, y is -5. When x is -4, y is -12, 4, 8, 12. And -5, -21. So our graph is going to look something like that. Let me check all these. I'm going to try to put this in the view of the camera over here and the answers. See, we got 5, 5A. Those are the first 3. These are the others. You see them now. I don't. I'm going to have to, I'm trying not to look. Every now and then I might get a little peek, but you know. It's kind of like when you're out looking at strangers, like you're out in public and you're kind of like looking around and you just don't make eye contact. You see everything, but you don't notice anything. You just kind of let your eyes unattentively wander. That's how I am when I see the answers here. Strangers, I don't want to make eye contact with. All right, 5. So 5A. Yeah, that's what it looks like. Yeah, as long as we cross it negative. Oh, no. Oh, yeah. We cross it -1 and 1. Yep. 5C. Yeah, their graph's a little less compressed than mine. It's more opened up, but we're good enough. And yeah, we got D. I need all my terminology, like local minima, local maxima, because if I remember correctly, when it comes time for calculus, I'm going to have to know those things because they matter when you're plotting derivatives. Like there's specific like landmarks, if I can call them that, graph marks that are very, very they I don't know what I'm saying. They're just very specific things. All right, 5e. Okay. How does the square root graph look? Isn't it something like, I don't know, let's plot some points. So immediately we see a 0, 0. And then when it's negative, you can't be negative. So there are no negative values here because they're not real. You can't plot an unreal number. So when x is 1, y is 1. When x is 2, y is... We're going to cheat. We're going to go simple here. I don't know the square root of 2. We'll go when x is 4, y is 2. When x is 16, y is 4. And when x is 25, y is 5. All right. Plot this bad boy. There's another feature that they just added to Krita 5.3 where you can like have your commands over here. So like if I wanted, I can always have, you can, it's like script based on Python. So I can come over here and click that and it'll switch me to the marker brush, size 6 pixel with an orange color. And then I can change it to stabilized. And then I can, when I go back, I can click another one that would change me to my writing tool, black weighted. But I haven't figured out how to set that up. It's just a new function. I'm going to do it eventually. It just saves me time. All right. Let's plot this bad boy. So we got a 0, 0, 1, 1. It's the one thing I don't like about the stabilizer. 4, 2, 4, 2, 16, 4, 4, 8, 12, 16, 4, and then 25, 5. Oh, yeah. That's the graph we know and love. The square root graph is beautiful. I gotta admire it for a second. I want to see. So at 100, way out here, we'd only be at 10. This thing just steadily climbs. It's a beautiful graph. Let's look here. You guys saw it earlier. I'm seeing it now. He said, I'm seeing it now for the first time. Yeah, we look like it. I mean, yet again, theirs is a bit more compressed, but all right. Well, now we're literally going to be that same graph, but 2 times in the y direction. So 0, 0. One, 2. I'm going to cheat here. So we're 0, 1, 4, 16, 25. Yeah, okay. 1, 2 would be, no, 1, 4, 16, 20. Let's do 9. I left 9 out earlier. 9, 16, 25. Square root of this times 2, so 4. So 6, 8, 10. All right, that's what we're looking like here. I've got to figure out how to set that up because I don't want to have to switch every time. All right, we got a 0, 0. And then we've got a 1, 2. Then we've got a 4, 4. We've got a 9, 6. 16, 8, 4, 8, 12, 16, 8. 25, 4, 8, 12, 16, 20, 24, 25, 10. So that, and that's what it looks like. Man, they're really, I don't like how they showed their graphs and their answer set. Negative 2 raised to the x. I want to see something. Okay. What do we got? What do we got? So, damn it. So, x is 0, y is negative 1. Man, I want to go with some unique stuff here to get some clean answers. What happens when x is negative 1? I do not like that. We're going to go simple with this. What happens when x is negative 20? Y is going to be so fractionally small. There's no good way to show this. Let's just show it. Negative 20. So we're going to be 1 over 400. No, 2 raised to the 20th power. God almighty. It's crazy. It's a million. It's a millionth. Negative 1 millionth. So it's so small that I can't really show it. We're just going to call it. I know that this isn't the way you would represent it, but 1 times 10 to the negative 6th. That's basically it. Just so that I can have some, because I can't plot that. All right, let's bring it in a bit. Let's bring it to negative 4. Something a little more reasonable. 2 times 2 is 4. Times 4, 16, negative 16. That's a bit more reasonable. We asymptote clearly at 0 on the x-axis, but okay, what happens when x is 1? 2 to the 1 is 2. Negative 2. 2, 4, negative 4. Ooh, that one's more reasonable. 3, negative 8, and 4 is negative 16. That's pretty much all we need. All right, 0, negative 1. 0, negative 1. Negative 20. I mean, we're pretty much at right there. We're close. And negative 4 is negative 16. Negative 4. Well, how the hell does that work? Something ain't right there. How could negative 4 not be between? Oh, I'm an idiot. It's not negative 16. It's negative 1 over 16. So it's a 16th. It's like that. That's how it looks. Yeah. So here we're still like, I mean, we're basically so close to 0, we might as well. Okay, so when x is 1, y is negative 2. When x is 2, y is negative 4. When x is 3, y is negative 8. X is 4, y is negative 6. So that's our graph. Yeah, that's how we look, I guess. It's much cleaner. No, that's not how we look. It is. I just don't like the way that everything's shown there. Maybe I'm trying to show it at too much detail. And the whole rough sketch thing is plotted on a 4x4. You only need a couple points to get the idea of the relationship. All right. So when x is 0, what am I doing? Y is, so 0 raised to, I don't care what it is what's 0 raised to the 0? Is it 1? I think it is. If I remember my math correctly. Oh, there's a domain error. 0 can't be raised to the 0th power. Gotta get that coffee in. Okay, so 0 plus, so it's 1. All right, when x is negative 1, negative 2, negative 3, negative 4. So when it's negative 1, what's negative 1 raised to the negative 1? I want to rewrite this really quick so I can see it better. 1 plus 1 over x to the... It's just 1 over x. Okay, that's a better way so I can visualize the relationship. So 0? 1 over negative, yeah, 0. Negative 2. So 1 minus a half is a half. Negative 3, 1 minus a third is 2/3. 1 minus a quarter is 3/4. What a weird ass graph that's going to be. Let's go way out here. Let's go to negative 20. Our bounds here. Oh man. 1 over 20. It's 1 minus a 20th. What is that? 19 20ths? So basically, we're going to asymptote around 1. All right. 1. So 1 plus 1 is 2. 2. So 1 plus a half is 1.5. So 3 over 2. 3. 1 plus a third is 3 over 3. 4 over 3. 4. 5 over 4. And 20 will give us 1 plus 1 over 20. 21 over 20. Right? Yeah, we asymptote around 1 again. Yeah, so we go. How do we determine the y asymptote? That's our x asymptote. The pattern here. The y asymptote is 0? Yeah, as we get closer to 0. Yeah, that one's easy. All right, this will be the last one. I think I gotta go. Control Shift S. 0, 1. Negative 1, 0. So negative 1, y 0. Negative 2, y is a half. Negative 3, y is 2/3. Negative 4, y is 3/4. Negative 20, y is 19 20ths. What if we were like 1/2? Where would that put us? Because you want to imagine this jumps back up, but it doesn't. You have to go infinitely fractionally small to realize that we're asymptoting at 0. And there's a way to see that from the formula. I just don't remember the pattern. Okay. 1, 2. 2 is 3 over 2. So 1.5. Yeah, so this one asymptotes out around 1, right? Yeah, so essentially, even though it's not very obvious based on the points, we do like this. Let's look at our guy. Yeah, that's exactly what we see here. We have an asymptote at 1. So you could never be 0 and you could never be 1. Y could never be 0 and x could never be 1. No. X can never be 0 and y can never be 1. Truly. You asymptote to those values. How's that looking hyperbolic? Is that how a hyperbolic graph looks? Okay. Well, that's it. Who's next? Let me turn all of these on. 6A. All right, that's later's problem. Sweet. Let's get back to it. Do some mathematics. Let f of x, pull up my notes. Let f of x equal 1 minus x squared and 2x plus 1. If. So 1 minus x squared is if x is less than 0. Oh, I added this. So I got a permanent graph I can just turn on or off in the back. Pretty sweet. Okay. 1 minus x squared if x is less than or equal to 0. So we've got x squared is greater than or equal to 0. Let me pull that back up. I said it last time, but I think I moved the microphone away. But I put this camera here, the one I'm pointing at now, so that I could pick the book up and show you the answers and stuff, and show you the questions, and not get it in the way of the mainstream. Also, I was hoping that it could be zoomed in enough where it was legible or visible. I don't think that's the case, though. All right, let's see. So, actually, I think that's right. And then over here, we are. Oh, what am I doing? We just plug it in. Oh, no, never mind. No. Yeah, I'm wrong. So f of x is equal to 1 minus. I'm just going to plug values in. So over here is when we're less than 0 or equal to. 1 minus 0 is 1. So when x is 0, y is 1. When x is 4, 1 minus 16, y is negative. I've already pushed us to our limits. When x is 1 minus 1, we're 0. When x is 2, 4, we're negative 3. 3 squared, 9, negative 8. 4 squared, 16, negative 15. Okay. All right. In this condition, for when we're greater than 0. Zero, 1, 1, 3, 2, 5, 3, 7. Oop. 4, 9. Yeah, that's what we'll do there. Okay. So 0, 1. X is 0, y is 1. Make that a bit smaller. So X is 0, y is 1. X is 1, y is 0. That don't make any sense. Oh, I'm an idiot. I went the positive direction. Obviously, that doesn't make any sense. I'm not paying attention to what I'm doing. Jesus. I'm going to have to stop making such stupid mistakes because it's going to slow me down massively. -1. -1 squared, 1, 1, 0. -2 squared, 4. -3. It's really just the inverse. -3 squared, -8. -4 squared, -15. Right? Yes. All right. So 0, 1, 0, 1. -1, 0, -1, 0. -2, -3. -3, -8. -4, -15. So we're going to look something like that at 0 and below, and then 0, 1. 0, 1, 1, 3, 2, 5, 3, 7. It's really just up 2 over 1. And 4, 9. And that is just a straight line. All right, that's what we're looking at on 7, 6. Oh, I'm an idiot. I mapped it. That's the answer to 7B. Tell you what we'll do. So I solved B first. That's sheer stupidity right there. Okay, no big deal. Let's just evaluate when. So f of -2. I love function notation. It's superior to y. Should always be a function of. If somebody's watching this that hasn't made it this far in math yet, function of is superior because you can do multiple variables. It can be a function of multiple variables. Maybe. Can you? Or is it always the dependent variable? I'm sure you can do a function of multiple variables. I don't know. I can't remember. I guess I'll find out. So -2, this is our case here because we're less than or equal to 0. So 1 minus -2 squared. 4, -3. And then f of 1, it's the other case, is equal to 2 times 1 plus 1. 2, 3. All right, let's check our answers. -3, 3, and our little graph. I'll take it here, let you see it. All right, See the answer? See, I'm not an idiot. Well, half an idiot. Okay, so 6 is done. Great. What's 7 got in store for us? We're almost done with this whole. They have a little section here. It says, if you have had difficulty with these problems, you should look at sections 1.1 to 1.2. Yeah, I'm going to have to go back through and refresh on everything. We'll make ChatGPT generate us a bunch of problem sets for all of these domains. Okay. What the hell are they asking me right now? F of x is equal to x squared plus 2x minus 1, and g of x is equal to 2x minus 3. Find the following function. I believe what it's saying is f of g. See, I think that little symbol there is telling me to do it like this. I think that's what it's telling me to do. And then I'll plug this into here. I think so. Let's try one. I'll check the answer and see what we get. So we got 2x minus 3 squared plus 2 times 2x minus 3 minus 1. So this gives us 4x squared minus 6x, so minus 12x plus 9 plus 4x minus 6 minus 1. So we got 4x squared minus 8x plus 2, right? Yeah, okay. All right, let's check this. 4x squared minus 8x plus 2. Yep, got it. Okay, so I know how to do these. So here, it would be something like this. Even though that's not the proper notation, the notation that they show here in the book is literally what you see there, like that. That's what it shows. This makes more sense to me. I can actually show that too. How do you type that, little guy? All right. So 2 times x squared plus 2x minus 1 minus 3 is equal to 2x squared plus 4x minus 2 minus 3. 2x squared plus 4x minus 5. 2x squared plus 4x minus 5. Got that. Okay, what's C say? So I plug G in the G, which gets plugged into G. Is that just a cube? Can I? No, surely it's not. Of course it's not. So first we'll solve for G of x. It's equal to 2 times 2x minus 3 minus 3. And then after that, we'll solve for G of... Okay, now I see why they represent it the way they do. Yeah, it's cleaner that way. If I just did it like this, that's, I guess, cleaner. Okay, 4x minus 6 minus 3. That's equal to 4x minus 9. All right, plug that in here. So 2 times 4x minus 9 minus 3 equals 8x minus 18 minus 3 equals 8x minus 21. Yep, we got it. Get really close. Okay, trigonometry. Part of me doesn't want to go back and review and just jump right into the calculus book. And part of me wants to go review. That way I don't mess up and I just feel like I'll be hindering myself if I don't go through. God dang. All right, let's make a new section really quick. Okay. Action. Section D. Question 1A, and B. All right, 1A says convert from degrees to radians. Man, I really got to find that sheet that I had. Okay. 300 degrees to radians. Damn, I don't remember how to do this. It says if you're having trouble, look at Appendix A. Oh, man. Oh, man. Oh, they got tons of reference pages here. So in the reference pages, they've literally got everything I could need. Table of intervals to show me my notation, special functions, the law of cosines, law of sines, fundamental identities, angle measurement. There we go. Pi radians is equal to 180. Pi rads is equal to 180 degrees. 1 degree. So pi over 180 rads is equal to 1 degree. And this doesn't say rads, it just says rad, pi rad. And then arc length is equal to the radius times theta, or theta. Okay, I'll have to remember that. Hell, that wasn't even Appendix A. Wasn't even Appendix A. That was just the Appendix A. Oh, they have a whole trig. There we go. That's what I'm talking about. Okay. Okay, I see. Yeah. Okay. I got what I need to do my pieces here. God, this is going to be such a great journey. I'm so glad to be doing this. So, really, I can multiply by 300. Well, so 300 over 180 times pi will give me radians is equal to 300 over 80. That's 30 over 18, which is 5 over 3. 5 over 3 pi radians. I guess you wouldn't even have to put radians. It's 5 over 3 pi. Man, good enough. Okay, what's the next one? Negative 18. Negative 18 degrees. I don't know. I think you can. So 18 over 180 pi is equal to 1 over 10. Oh, negative 18. So it's negative pi over 10. Let's check. Yep, got it. Ooh, these are cool. It's cool that we've got a couple of ways to measure angle or represent an angle or angular. So we've got obviously theta measured in degrees, theta measured in radians, and then we can also use square I to show rotation. All right, number 2. Oh, let's open up a new. Question 2. 2A. Hold on, sorry. Okay. To convert from radians to degrees. Convert from radians to degrees. Okay. Copy and paste. 2B. All right, 5 pi over 6. Our formula was what? Pi over 180 is equal to 1 degree. That was our formula, right? What was the other one? What was it? 2 pi is equal to 360. Is that what the other? Hell no, I can't remember. Oh, pi is equal to 180. Yeah, that makes sense. Obviously, 180 over 180. Okay. So here we do the opposite. We want degrees. So what we'd multiply by 180. Right? Last time we divided by pi over 180. What do we multiply by 180 over pi? Yeah, that's what we do. Pi's cancel. 180 times 5 is 500 plus 163, 2400. So 900. 5 times 180 is 900. Yeah. So it's 900 over 6. 150 degrees. Let's check that one. Yeah, that's correct. Okay, B. Convert from radians to degrees. 2 radians? Was that trying to trick me here? 2. I want to say this would be just, there's no conversion. You just got to know that, man, every piece of me wants to say 2 radians is equal to 720 degrees. Let's check. No, nowhere near. I should have done the conversion. I'm an idiot. I should have done the conversion. So it's 180 over pi. So it's 2 times, which is equal to 360 over pi, which is equal to, well, I got to use a calculator. I'm not a genius. 114.59, approximately 114.59 degrees. Yep. Or 0.6 is what they've got. They rounded. Okay. Question 3. Before I come back on here next time, I'm gonna make damn sure I get my old calculus notes. There's 2 things. I had a nice diagram to show the unit circle, and then I had another sheet I was able to make when I took the AP calculus exam, or whatever I could fit on one page, I got to write on to use on the exam or to prepare for the exam. I can't remember. I should prepare these in advance. There's only a single question. Find the length of an arc of a circle with radius 12 centimeters. Find the length of an arc of a circle with radius 12 centimeter if the arc subtends a central angle of 30 degrees. If the arc subtends a central angle of 30 degrees. Central angle of 30 degrees. What did we say? S is equal to R theta? Yeah, that was the formula. S is equal to R theta. That's not theta, that's theta. Find the length of an arc of a circle with radius 12 centimeters. So, arc length is equal to 12 times 30. So, 36, 360. S is equal to 360 centimeters. Is that correct? No. Do they want it in radians? No, that wouldn't make any sense. Oh. Hmm. Yeah, I don't know. Can I multiply degrees times centimeters? I don't think so. The answer they've got is 2 pi centimeters. How'd they get that? Because 30 is what? 2 pi? 30 degrees is 30. No. Am I doing wrong here? Do I got that formula proper? I hate how these books will only give you the answers to odd numbered exercises. I really despise that. Sorry, I got distracted looking at the appendix here. I really despise that. It's like, I paid for the damn book. Give me everything. All right. I swear those books better not do that. It's like, I'm a grown ass man. All right. Where's my trigonometry formula? Yeah, it's S is equal to R theta. Hmm. Okay, let's try it. Maybe I'm looking at this wrong. So 30 pi over 180. 1 over 6. Ah, it makes sense. Yeah, that makes sense. Pi over 6. It is in radians. You got to convert to radians, I guess. So it's 12 pi over 6. S is equal to 2 pi centimeters. Okay. Question 4. This one's a 3-part question. Whoa. So, find the exact values. For B, for C. All right. A is tangent pi over 3. I'm going to need my damn unit circle. Yeah. We might call it here, and I dig up my unit circle. I don't know. Let me search the internet quickly. See if ChatGPT will generate a unit circle image. So sine is what? I don't remember. I don't not remember this stuff. Sine is something like cosine over sine. Okay, so let's write these down really quick. Secant of theta is equal to 1 over cosine of theta. Oh man, I got a lot to remember. Tangent of theta is equal to sine over cosine. Oh yeah. There's there was some sort of thing my teacher, some saying she had for us to remember this. I don't remember. There was, though. There was a saying my teacher had. That's okay. I'm just going to read the back of the book tonight. All right, now I'm looking at the unit circle. Tangent, which is sine over cosine. And I believe on the unit circle, it goes sine, cosine are cosine, sine. So it's pi over 3 is, so we've got square root of 3 over 2 over 1/2. Jesus. Square root of 3 over 2 times 2 over 1. So it's the square root of 3. Is that right? Yes. Okay. We're in business. All right. Sine of 7 pi over 6. That's B. So 7 pi over 6 is negative 1/2. Right? Right. All right. Secant 5 pi over 3 is equal to 5 pi over 3. Where's it at? So it's 300. I want to say secant was what? 1 over cosine. So 1/2. 1 over 1/2. Which is equal to 1 over 1 times 2 over 1, which is equal to 2. Yes. All right. I hate that the insert button is how you add a new one. I could change it, but it makes sense. I just hate reaching over the keyboard to a weird. Okay, so it only has 1, 5. Express the lengths A and B in the figure in terms of theta. express the lengths A and B in the figure in terms of theta. So just so everybody can see, we've got something that looks like this. Theta 90, 24, A and B. All right. How the hell do we do this? I'm going to look at my trig functions. Yeah, there we go. Man, I got to remember I forgot about the double angle formulas. I bet there's a video on YouTube, precalculus in one video. I bet. It's got to exist. So how can I use the sides? So we got the law of sines. Oh no, we could just use regular old Sakatoa. Yeah, that's what we'll use. So what was, I can't even remember it. Sine of the opposite is equal, sine of theta. Okay, yeah. Sine of theta is equal to opposite over hypotenuse. So the sine of theta is equal to A over 24. And then the cosine of theta is equal to B over 24. It's amazing everything we figured out. So A is equal to 24 sine of theta. This seems so simple. B is equal to 24 cosine of theta. Surely I got this wrong. 24 sine of theta, 24 cosine of theta. All right. Okay. Here. If sine of x is equal to 1 over 3, secant of y, well, it's not sine of x, it's sine x, is equal to 1 over 3, and secant y is equal to 5 over 4. Man, I forgot my trigonometry. Where x and y lie between 0 and pi over 2. Evaluate sine of x plus y. Jesus, I got no idea what I'm doing. No idea what the hell I'm doing here. I gotta try to put some shit together. Gotta make sense of all this, so. Boy, tangent's a weird graph. Addition and subtraction formulas. So sine of x plus y is equal to sine of x times cosine of y plus cosine of x times sine of y. I don't know if that's going to help me here. I think I'm just going to have to use my fundamental identities. There's something there's something I'm not seeing. If sine of x is equal to 1 over 3, and secant of y is equal to 5 over 4, What am I? I'm missing something. Can I just do the opposite and get x and y? Let's try. I just gotta try something. Let's multiply by 180. But if I multiply by pi over 180, I'll end up with pi over 540, which just makes no sense. The hell am I not seeing here? I don't know. I'm gonna have to ask ChatGPT because I don't understand this one. See what it gives us. So sine of x is equal to a third. Secant of y is equal to 5 over 4. Yeah, so we know that both are in quadrant 1. We need sine of x plus y. Oh, so it was going to use the identity. Sine of x cosine y plus cosine of x sine y. This is, trigonometry is truly beautiful. This is cool. Okay. I see what it's doing. Now find cosine of x. Sine squared. I'm going to need some work here. I'm going to need a lot of work here. I'll tell you what, there won't be videos for the next few days because I'm going to go through and watch a comprehensive video on algebra, geometry, trigonometry, and what was the other one? Like special functions. Yep. Yeah. And I want a comprehensive take, and then I'm going to come back and work out a problem set on camera then. No way I can sit here and watch a video on camera. You know, it'd be silly. Because while I could just copy this and move on to the next problem, I don't want to. I'd be wasting my time. I could get them, but I want to truly understand them. So yeah, I think I'm calling it for today.